Welcome back. Now let us look at problems that involves resistors that are connected in parallel. So we have in this circuit here we have 12 and 24 connected in parallel. You can see that there is a branch here. Okay. There is a junction here. Some current is going that side and some current is going that side, and the total current is current 1. And I've put one resistor here, and that is 1 ohm. How do we solve for current 1, current 2, and current 3? Well, this is simple. Okay, if you watched the first video on this, then this is simple because you follow those basic hints that I highlighted. So we have to solve for the total resistance first. Now in this circuit there are only 2 resistors that are in parallel. That is this one and this one, and they are just 2. So we can solve for their combined resistance. Let's say this is RA and they are just 2. Okay, we said that can be R1, R2 over R1 plus R2. So for these 2 we have 24. We can label N to be our R1, then times 12 over 24 plus 12. So RA in this case, that is the combined resistance for 24 and 12. If you use your calculator, this will give you 8 ohms. This is the combined resistance, which implies that we can substitute these 2 with one resistor which is just 80 ohms. And if that's the case, these 2 are giving us 8 ohms. This simple circuit here reduces to this. This simple circuit reduces to this. We'll have 1 ohm connected in series now with the 80 ohms. We've moved from this circuit to this one here. So this circuit is the same as just this circuit here. Okay. Now, do we know the current 1? No. Do we know resistor 1? Yes. Do we know the other resistor? Yes, that is 8. So how do we solve for current 1? How do we solve for current 1 or the total current? You know that this is the current coming straight from the battery, so that will be the total current. So current 1 will be the total current here. And the voltage drop in this case will be 3 volts, okay, across the 1 ohm resistor. The current will be 3, the voltage will be 3 volts. Now, before we do that, let us compute for the total current. Let us compute for the total current. So if we compute for the total current using Ohm's law, we have to divide total voltage over total resistance. Now this is now a series circuit. We have 1 plus 8, that will give us 9, and this will be 27 over 9. Okay, and this here will be 3 amps. So the total current I1 there will be 9. If you want to know now the voltage across resistor 1, the voltage across resistor 1, that will be voltage 1 times current 1 times resistor 1. That will be the voltage across here. Okay. So the total current here, we've said this will be 3 amps. This will be 3 amps. That is the total current. And that total current is now the current that is passing through resistor 1. And it is the same current that is dividing here. If you want to know now the voltage across here, or the voltage across these 2 resistors here, we can still use Ohm's law. So voltage across this 1 ohm resistor will be the current times that resistor, which will give us 3 volts. And that is the 3 volts which I wrote here. Okay. And then to get the voltage drop here, you can say that will be 27 minus 3 volts. That will give you 24 volts. That will be the voltage drop across the 8 ohm resistor. So the voltage drop across this one here is 24 volts, and the voltage drop across this one here is 24 volts. Okay, and that is the statement with which I've added here. So if this is the voltage drop across the first resistor there, then the R2 resistor and R3 are in parallel, then we'll have the potential difference of 24. We'll have the potential difference of 24. If you want to get the proof, you can still say the combined resistor here is 8. The combined resistor here is 8. So if you want to know the potential difference across that, you can still say V is equals to current, which is the current passing through these two resistors, which is the total current in this case, times the resistor itself. Okay, and the current will be 3, and that will be 3 times 8, so that will still give you 24 volts. So that is proof enough that the voltage across the two resistors that are connected in parallel is the same. Okay, or you can get that 24 using this. Yeah, so voltage 2 is equals to voltage 3, which is 24 volts. Now what will be current 2, since we know the voltage drop? Okay, since we know the voltage drop, this current here will be now voltage, okay, over resistor, and the voltage drop here is 24 volts, which we've calculated here, and the resistor there is 24. This will give us current 2 equivalent to 1 amp. Okay, equivalent to 1 amp. Where is that? I've written it here. So current 2, that is 24 over 24, which will give us 1 amp. Similarly, if we want to get now, since we know the voltage drop across the 12 ohms resistor, that will be 12 divide into the potential difference, which is 24. That will give us 2, which I've written here. That will be 24 is the potential difference across resistor 3, which is 24, over the resistor itself, that is 12, and this will give us a current 2. So that's how you handle problems that involves resistors that are connected in parallel. In the next video, we'll also solve one more problem on resistors that are connected in series and parallel. And then you proceed to Kirchhoff's law. See you in the next video. Just don't forget to subscribe.